and this is say A prime, B prime, and C prime. So I'm going to say that two triangles are similar to each other, okay, if the ratio of say perpendicular to the perpendicular and the ratio of base to the base and hypotenuse to hypotenuse are equal. So these two triangles are similar if A by A prime and B by B prime and C by C prime are equal to each other. So if they are equal to each other, you're going to say that these two triangles are similar. So another way to make sense of it is to say that this bigger triangle is a scaled version of it. It's a zoomed version of it. So imagine you have a picture and you are just zooming it out actually. So when you are zooming it out, everything in the picture will increase at the same rate actually. Increase at the same rate, okay? And that rate is what this ratio, let's call this K actually. So in other words, A is K times of A prime, or A prime is K times of A, or B prime is K times of B, and C prime is K times of C actually. So this triangle is a zoomed version of this. So when the version is zoomed, then the line becomes this much bigger. So this has a length and this has a length. And this line becomes this line, and this line becomes this line. But since you are zooming in the picture, the rate, so for example, if this is the double of the B, then this would also be the double of the B actually. If this is double of the B, then the C prime is also going to be the double of B. So it's like zoom. So when you zoom, everything, the size of the picture increases at, every part of the size of the picture increases at the fixed and the same rate actually. So it's not like, I have a triangle, this, but the other triangle that I have is like this actually, where the bases are same, they are of the same size, but not the perpendicular and hypotenuse. So you're going to say these are not two similar triangles. This is not a zoomed version of it, because these two parts are zoomed, but this is not zoomed. So if you zoom a picture, every part of the picture will zoom at the same rate actually on your computer. So the zoomed version, so if one triangle is a zoomed version of other triangle, then you're going to say that these two triangles are similar. And once they are, zoomed version of, once the two triangles are similar, that means that their corresponding ratios would always be same. If this is double of this, then this would also be double of this, and this would also be double of this actually. Okay? So these are two what you call the similar triangles. So this is basic trigonometry. I hope you have done it in your high school, level, and you have also done it in maybe your calculus and the first pre-calculus course actually. Now my question is that this bigger triangle and this smaller triangle are similar to each other. So this small triangle and the big triangle is similar to each other. So in other words, so this bigger triangle is a zoomed version of this smaller triangle. And if this is the case, then if I take the ratio of the base of big triangle and the base of, for example, small triangle, this should be equal to the ratio of say height of the big triangle versus the height of the what do you call the small triangle. So in other words, I can say that since these two triangles are similar, so the 2 by what do you call 2 by R should be equal to what do you call So this is 2 and this is r, so 2 by r should be equal to 4 by h. Going to be 4 by h actually. And hence I can express r in the terms of the h actually. So if I take the reciprocal, so it's going to be r by 2 equal to h by 4. Okay, and hence r would be equal to h upon 2. So this is what the relation that we get actually. So if I use this relation in this formula, then my formula would give me a relationship between volume and height only. So let's do it. Let's do it. So the V then is going to be pi upon 3, r square is, what do you say, h by 2 square and times h. So you're going to get y equal to pi over 4, this will become 12, okay, and h cubed. So now I have a relationship that is purely between the v and h, and things are known to me, so using this I will try to figure out what we call the derivative of this. So let's try to calculate the derivative with respect to time, and this would be same as pi by 12 as the derivative of h cube with respect to the time. And on this I can apply what you call chain rule. So by chain rule this will become 3h square times dh by dt, and here I have dy by dt. Okay, so this will become what, 3 and 4. So if I simplify this stuff, you're going to have dE by dt equal to pi by 4 and dh by dt, and obviously there will be an h square. So now what I need to do, I just need to substitute the values. So the first is, it is given to me that dV by dt is 2, and initially the water is 3 meter deep. So in the beginning, okay, when you started pouring water, or at some instant, you know that the water is 3 meter deep. So when you say that you have a 3 meter deep, that means the height is 3 meter actually. Height is 3 meter. So you just need to substitute, for example, 3 here. So 3 square times pi by 4 times dh by dt. So taking everything on other side and doing calculation will reveal that dh by dt, in other words, the rate at which the water level is increasing, okay, is equal to what do you call 0.0 is approximately equal to 0.28 okay, meter per minute. So that if the volume is increasing at 2 meter cube per minute, then the height would increase at 0.28 meter per minute actually. So this would be the rate. And since this quantity is increasing, so you're going to say that the height of the water is increasing in the cone actually. Okay. So again the same philosophy. Read the problem very carefully, try to make a picture, try to identify the quantities, try to find the relationship between them, identify what is known and what is given to me, and then using the relationship try to calculate the unknown rate through the known rate actually. So pretty much straightforward. So this is example 3. I would like to do another final example. A very interesting example. And then move to the next topic. So final example goes like this. Imagine this is a path. Okay, this is ground or path. And on this path, so there is a guy who is walking actually. Who is walking? Okay. I don't know. This way. He's walking this way. And imagine here there is a torch light. Okay. There is a torch light actually. So there is some, maybe a bulb or a light source actually, which is throwing the light all over. Okay. Maybe it's a kind of a light that focuses actually. I mean, if you have seen, for example, some of the prison escape movies, okay, then you see that in the jails you have these big lights actually, which just revolve around and they try to track any activity that is going on within jail or on the boundaries of the jail actually. So you have this light and you try to track the person. Okay, and once you track the person, the light will follow that person actually all the way wherever it is going. So imagine there is a light source. Okay, so imagine my drawing is bad. Imagine there is a light source. That light source is throwing some light actually and tracking this person. Okay. That light is trying to track this person. Okay. This is the light actually, so this guy is moving away, maybe a prisoner trying to escape, and here's a person who is sitting there who is trying to track him actually. Okay. Let's assume that this is the point that is, this is the point that is right in front of what do you call the light. Okay, right in front of the light. So in other words, this is the distance between the path on which, the road on which this person is walking and the light actually. So this is the shortest path actually. Okay, maybe this is the shortest path between the path and the light actually. And let's assume that this is known to you, that this path is 20 meters. Okay, this path is 20 meters. And imagine this is given to you, that the distance between this point, which is the shortest, which is the point of the shortest path between the light and what do you call the road, the distance between this point and the person is x actually. Is x. Okay? And imagine that I try to, say for example, make a triangle out of it. Okay? I try to make a triangle out of it, and this angle is theta. So in other words, you need to revolve this light with some angle to track this person actually. So this is the angle actually. Okay? So this is the angle. And the picture that you are getting here is really a right angle triangle. Okay? The right angle. The rest is just a shadow. We know that the shadow is going to be bigger than the size of this actually. Okay? So once again, a person is walking on a path, okay, and there is a light source that is trying to spot that person, okay, and is throwing the light on that person. The person is moving this way, okay. The distance between the person, the light, and the path on which the person is walking is 20 meters, and the distance between this point and the person is what do you call x. Okay, so as the person will move this way, the distance x would increase, and this light also has to change the angles actually to track the person actually. So if the person would move this way, the angle will reduce, and if the person is trying to run away, then the angle, this angle is needed to be increased actually, okay, so that the person can always stay within the light. Okay, so I hope that you got the sense of it actually. So this was my step 1. So what I did in step 1, that I read the problem and I tried to make a picture of it, a bigger picture of it, and incorporate some of information. Okay, and now the question is to what? Okay. The question is, so what are the quantities that I'm interested in? So I have read the problem, and the quantities that I'm interested in is that is these two quantities, x and theta. So if as this person is moving away, then x is increasing, then the theta has also increased actually as this person moves. So the question is, you know, what should be the relationship between x and the angle theta actually. So the theta by which you rotate your, what do you call, your light source. Okay, so the quantities, step 2, the quantities that we obtained is x, and we know the meaning of x and what do you call theta. Okay, and the next would be what you call the step 3, and how to find the step 3. So step 3 is to find a relationship between x and theta. The question is, how can I find a relationship between x and theta? So the relationship can be found by assuming this pink thing as a triangle actually. So it's a right angle triangle. So if it is a right angle triangle and this is the angle, then this would be base, this would be perpendicular, and this would be hypotenuse actually. Then take any ratio. So for example, if I take tangent theta, then I know that tangent theta is perpendicular upon base. So it's going to be x upon base is 20. So this is the relationship between what you call x and tangent, x and theta. The next is step 4. What do you call step 4? The step 4 is what is given to me and what is the thing that I need to, what do you call, find. So the first thing that is given to me is that imagine that this person is moving on this road at a rate 4 meter per second. Actually, they are 4 feet per second. Okay, so the person is running, you know, on the road in this way at the 4 feet per second. So in other words, this distance is increasing at the rate this distance between this point and the person is increasing at the rate 4 feet per second. So the dx by dt is 4 feet per second. So this is given to me. The question is, what should be the rate at which the theta should vary so that the person can always stay in the light actually. Okay. So the question is, so the thing that I need to find is d theta by dt. So if x is changing with respect to time, then what should be the rate at which the theta should change actually. And you need to keep one thing in head. So if people are, what do you call, inventing different kind of technologies, sensors, and different kind of things that are automated, which are, for example, doing things automatically. Okay. The programming of such devices basically is based on the programming of such a relationship, actually, where the machine knows the relationship between the quantities, for example x and theta, and machine knows the relationship between the rates, and if one of the rate is given, it just calculates and manipulates the other and gives the command to, for example, this light to move in a certain way so that the person can be tracking it. So this is just one example of the machine. So most of the machines that work, okay, for example, some of the cameras are really automated cameras. When they, spot a motion, they just start start rotating with the motion, actually. Okay. So how these such cameras do the calculations? So there are similar models which are being implemented to do the job. Okay, so dx by dt is given to me. The rate at which the person is running away is given to me. The question is, what should be the rate at which this should be rotated so that the person stay in the light, actually. Okay. So it is given to me. Okay, it is given to me that in the beginning. Okay. In the beginning, when the person was spotted, for example, for the first time, so like here, the security guard is searching for someone who is, say, for example, moving around in premises. So when this person was spotted for the first time, its distance from this point was 15 meter, actually. 15 feet. So the x was 15 feet initially. So when this person was spotted for the first time, its distance from that base point was 15 feet, actually. The question is, can I find d theta by dt? The answer is not a big deal. Why not? So how to deal with it? So in order to deal with it, I need to do the differentiation of this, actually, the both sides. So let's do the differentiate. So step 5 is to take this relationship, say tangent theta equal to x upon 20, okay, and differentiate both sides with respect to t. So differentiate tangent theta with respect to t, and you're going to have 1 over 20 dx by dt. On this, I can apply the chain rule. I can say that this is equal to d by d theta of the tangent theta times d theta by dt. Okay? And from this, I can deduce that I have secant square theta d theta by dt. This is equal to 1 over 20 dx by dt. While I know that secant square theta, the secant theta is 1 upon cos theta. Okay? So I can replace secant square theta by 1 over cos square theta, and I can throw that cos square theta on the other side. So this is going to give me d theta by dt equal to cos square theta times dx by dx by dt. So this is what is given to me. So in order to find d theta by dt, now you need two things. Number one, you need dx by dt, and you also need what do you call the cos square theta. The question is, how can I find this theta? The answer is, we can find this theta from this information x. And how can I find it? So let's redraw that triangle that we have there and try to find the thing. So that I have a base of a triangle that is 20 meter, and this is my x, and this is really what do you call, okay, and I have an angle, this actually theta. Okay. So the question is, if I know that x is 15, can I find a theta? The answer is yes, why not? So just take, for example, say tangent theta, okay, or maybe I can take, for example, cosine theta. So in this triangle, take cosine theta. So the cosine theta is going to be based upon hypotenuse. By the way, I can, using these two, I can determine hypotenuse. Okay, I can determine hypotenuse. The other way could be that, okay, again use tangent theta and use 15 by 20 and try to figure out the theta, and then substitute that theta into cos square theta, and then calculate the value of the cos square theta, and then, cos square theta is known to you, dx by dt is known to you, so you can calculate d theta by dt. The other way could be that try to directly figure out cos theta, but for the cos theta you need base upon hypotenuse. But how can I find the base? So if I know the base and perpendicular, can I find hypotenuse? The answer is yes, actually. So the hypotenuse square is going to be 20 square plus 15 square, actually. Okay. So, and by the way, here the hypotenuse would mean the length of the beam, actually. Okay. The interpretation of the hypotenuse would be the length of the beam. So the h, after calculating this, is going to be 25. Okay. So the cos theta is going to be based upon hypotenuse. In other words, 20 by 25. So the cos theta is really 4 upon 5. So this is really the cos theta. And once you know the cos theta, just substitute the value here. Hence, my d theta by dt is going to be 4 upon 5 square times dx by dt, which is 4. And if you simplify this stuff, you're gonna get what you call 0.128 radians per second. Okay. So the unit of the theta is radians, and the unit of the time is second. So the unit for the d theta by dt should be the radian per second, actually. So this is the rate if the person, okay, if a person is running away at the rate 4 feet per second, the angle should, so the device, this angle should vary with 0.128 radians per second. Obviously, when this person is, running, okay, the security guard is not going to make such calculation and then, rotate actually the camera with such angle. But imagine that you implement this stuff, this model, and make a machine, actually, an automated camera, an automated light, actually, that can spot this. The automated machine can do these calculations like that, and hence make a decision, actually, that okay, so once I calculated this, the machine is going to make a decision that now I have to rotate quickly this person with this person at the rate, for example, I need to, in order to spot the person, I need to rotate the light at 0.128 radians per second. So in other words, such calculations, are, the machines can do such calculations very easily and quickly, and hence make decisions based on it, actually. Okay. So this could be a very practical kind of a situation. So I hope all this is making sense to you. So there will be some problems that I am leaving for you to work out, and we will carry on this discussion even further in the next part.